Let's start by exploring the basic concepts that lay the groundwork for understanding machine learning. Machine learning is a subset of artificial intelligence. The algorithms we explore in this module focus on building systems that learn from data and that improve over time to perform a task without needing to be explicitly programmed. Imagine teaching a computer to recognize patterns and make decisions based on past experiences. This is the essence of machine learning. It's what enables quick draw to make an estimation of what you're drawing. Perhaps the simplest type of machine learning to understand is supervised learning. We train the model using a labeled dataset in which input data is paired with the correct output, like a teacher guiding a student with examples. If we wanted to teach a computer to recognize cats in photos, we'd provide it with many images labeled as cats or non-cats. The model learns to associate specific features of the cat images with the label cat to enable future predictions. This is often an iterative process repeated until a given standard is achieved. By contrast, unsupervised learning works with unlabeled data. Here, the model tries to identify patterns and relationships within the data without external guidance. The data can be relatively simple or remarkably complex. One common application is clustering, in which the model groups similar data points together. Marketers use clustering to segment customers based on purchasing behaviors, enabling more targeted marketing strategies. Unsupervised learning is invaluable for uncovering hidden structures in data and for tasks such as market segmentation, anomaly detection, and recommendation systems. Humans are good at noticing structures and patterns in data, but AI tools can look at more dimensions and larger datasets to find interesting and useful patterns and groupings in the data that humans might not see. Whether this is detecting signs of cancer that a human doctor might miss, or identifying attempts to violate cybersecurity protections. Deep learning, often used in both supervised and unsupervised machine learning, uses networks of artificial neurons to model complex patterns in data. Within these networks, the neurons are arranged in layers, typically consisting of an input or visible layer, a number of hidden layers, and an output layer. Each neuron processes data slightly differently, and training involves adjusting the connection strengths between the various neurons until errors in the outputs have been minimized. We will look at this in more detail later. Deep learning excels in tasks such as image recognition, language processing, and generating synthetic data. Finally, we have reinforcement learning, the traditional carrot and stick approach of teaching. This involves an agent or piece of software that interacts with an environment to achieve a goal. The agent learns by receiving feedback in the form of rewards or penalties according to its actions. Over time, it develops a strategy that maximizes its cumulative rewards. Reinforcement learning is used in areas such as robotics, game playing, and autonomous vehicles. Reinforcement learning is particularly exciting because it enables machines to learn complex behaviors through trial and error, much like humans do.